And I want you to draw a y-axis too. So this is a graph, and just imagine that the x-axis is waves. And now imagine there's a dolphin or a fish. Okay? And here's the fishy. I really don't know how to draw a fish. Here we go. Here's the fish, and it's going to jump out of the water. So I'm going to draw a little parabola. It's going to jump out of the water and then come back in the water right here. So here's the point it reaches, here's the point it started, here's the point it ended. And imagine this is our x-axis now. Notice that it was in the negative, below the x-axis, then it went positive and below. Could the fish jump out of water and not touch the x-axis? No. It couldn't go from here to here, not in our world, right? It has to go through the x-axis and through here. That's all the intermediate value theorem is saying. That if the fish goes from here to here, it has to pass through 0, because there's going to be a sign change from where the fish is in the negative to the positive. It has to go through 0. That's all it says. Okay? So here's it, not in English. If A and f of b have opposite signs, then there exists at least one value of c between a and b, which f of c does equal 0. So that's pretty much what I just explained. So to show that, when it says show that the polynomial function this has a real 0 between 2 and 3, it's asking about your y values. And these are the x values that they give us. So how do I find the y value when x is 2? Plug it in. Very good. So write f of 2. That's what we're finding. And I'm going to rewrite this, but I'm going to put 2 for all the x's. So 2 cubed minus 2 times 2 minus 5. 2 cubed is what? Y'all know this. 8. Ooh, I need to have a perfect cubes test. Maybe that will be coming up. Alright, negative 2 times 2. I can't have multiplication now. That's just sad. Alright, 8 minus 4. Minus 5. Very good. So the y value at 2 is negative 1. Now we need to find the y value at 3. So again, just plugging it in for x. Alright, let's see if y'all know 3 cubed.
27.
Yes, 27 minus what?
6.
Minus 5. So 27 minus 6 would give us what? Minus 5?
16.
That's correct. Now what's significant about these y values? How do we know that it passed the intermediate value theorem? Yes, there's a sign change. It goes from positive to negative, so it had to go through which value? 0. Had to. So the intermediate value theorem works for this polynomial. Alright, we won't do a lot of these, so I'll mark off D. I just want you to do B and C on your own. Just B and C. So show that it works. If it doesn't, put an X instead of a check if it doesn't work. Oh, while y'all are doing that, I want to talk about tomorrow for just a second. Does everybody know where they're supposed to go?
No.
Okay. No. Seniors will come here and go to your first period class, and then they'll tell you where to go from there, and you're going to be taking a practice ACT test. Or you can opt to take a finance class, I think. And then y'all will leave at 12:45.
Wait, we doing what? We gotta do like, we said, what is a finance?
Like you can pick to do like a finance class, like balancing a checkbook, signing up for FAFSA, paying bills, taxes, all that kind of stuff. Or you can take a practice ACT test.
What is fast?
We're going to find out.
What is fast?
It's like financial aid for college. You can't pay your tuition.
Wait, what is fast? Wait.
All right, get started. Focus back.
No.
That's fine.
Wait, which one? What is fast?
FAFSA is financial aid, so if you can't pay your tuition, you take out loans. You borrow money from the bank. You have to pay it back. And it's interest.
That doesn't look right.
It is.
Are you sure?
I'm sure.
Are you positive?
I'm positive.
All right.
All right. Somebody tell me what f of -3 is. What they get for that one? You can just say it out loud. 12. Anybody else get anything different? I got -42.
I do too.
But this is for when you plug in -3. But let me ask you something. Cade pointed out, he's like, do I have to work out the whole problem if I see it's going to be negative? No, we don't care what the number is. We just care about the sign change, right? But let me show you how you get -3. If I plug in -3 for all of these, what is -3 cubed?
27.
Yes. What's -27 times 3? -81. This would be a plus 30 and plus 9. So then that'll give you this right here. Alright. What did y'all get for f of 2? I hear 5. That is correct. So what's significant? The sign changes. So we had negative, then a positive. So did the intermediate value theorem apply?
No.
Yes. It had to go through 0. Alright. What did y'all get for f of 0? Very good. What did y'all get for f of -1? 1? Everybody get that? So did the intermediate value theorem work? Yes. So in short, somebody just tell me a shortcut or a short version of how do you check for the intermediate value theorem? When you plug what in? Yes, that they give you. That's all you're checking for. So for example, if you got like 2 and 5 for one of them, would the intermediate value theorem work? Because it didn't change what? That's it. Alright, flip it over. Now we're going to review what we did from Friday mixed with a little other stuff. We're still working on just graphing polynomials. I don't think we've graphed them yet, but we're going to graph them today based on these 5 things. The first thing, number 1, is talking about leading coefficient. Remember when we talked about in behavior on Friday? Whether it's going to go up and down, or both up, or both down? Okay. Yes.
Are we not doing the turning point of the polynomial?
Oh, yeah, I guess we'll go over that, sorry. Turning point's just simple. If it has degree n, and what's the degree of this polynomial? 4. Y'all remember that from Friday?
Yeah.
The highest exponent. So the degree here is 4. So whatever the degree is, the turning points is going to be n minus 1. So whatever your degree is, just minus 1. So this will have how many turning points? Yep. Because the degree is 4, so you just subtract 1. And here's what I mean by turning points. Put a star by these. Turning points are when it goes from increasing to decreasing, or from decreasing to increasing. Whenever it changes direction, those are called turning points. That's all it's saying. Like here's the function, x to the 5th, so this has degree of 5. So how many turning points would this have? 4, and it does right here. Alright, now flip it over, sorry. Alright, back to leading coefficient. So we need the degree and if it's positive or negative. What's the degree here? Very good. So is this even or odd? Odd, because 3 is an odd number. And then this one's not in factor form, so we just look at this first coefficient. And what is this coefficient? Is it positive or negative? Positive. So odd and positive. Odd, do they have the same in behavior or different in behavior? Different, if it's odd. Do you remember which one? Yes, it's going to go down first and then up. If it's odd and positive. If it was odd and negative, it would go what? Odd. Odd and negative, it would go up then down. Opposite. Okay, so we determine in behavior. Number 2. Yes. The first number out front is positive. 1. Alright, number 2, we're finding the x-intercepts by setting what to 0? Y. So this is going to be x cubed minus 3x squared equals 0. So just the original set to 0. And we have to factor. How do we factor this one? Good. They both have what in common? X squared. So what would be in the middle if I took it out? Very good. Everybody good there? So when we set both these equal to 0, this will give us what? This will give us. Now, for the multiplicity part. The multiplicity is just your exponent. That's on the outside. So what's the exponent here? So this has a multiplicity of 2. The exponent out here. So this has a multiplicity of 1. And that'll come in handy when we graph it. No. Alright, number 3. We are finding the y-intercept. We set what to 0? X. So right here the y-intercept would be 0. 0, 0 is the y-intercept. Alright, we're not going to worry about the symmetry part, so you can mark out number 4. Number 5. Turning points. What was the degree of this?
3.
So how many turning points? 2 turning points. TP. That doesn't mean toilet paper. Alright, now we can graph. Okay, so let's graph the points that we have. That's these 3. So we'll graph 0, 0 for our y-intercept. And 0, 3 for our x-intercepts. Well, we already have 0 here. We just need a 3 right here.
Miss Horton?
Yes.
Did Love and Modern make it in?
Yes, ma'am. Here's your starty.
Alrighty, thank you.
Okay. Now we can graph or just draw the end behavior. So the end behavior on this side, is it going to be going down or up? Down. That came from here. So just draw an arrow anywhere pointing down on the left side. And then on this side, anywhere pointing up. Again, this is a sketch. It's not going to be perfect. Yes? Okay. Now, here's where the multiplicities come in. Do y'all remember what I told you what even multiplicities do?
It's like, and then go over it.
They bounce off that point. So, like when the graph reaches 0, it's going to bounce off of it, which means it's not going to break through it. It's just going to hit it and bounce back this way. Kind of like when you kiss somebody. You can't go through them. You just like kiss and then come back. Not that y'all should know anything about kissing, because y'all too young for that. But anyways. Then it comes back here, and then this one has a odd multiplicity, so is it going to break through or kiss the graph? or bounce back. It's going to break through. Good. And it goes up like that. Again, I don't care what's going on here as long as it has the right x-intercepts, the right y-intercept, and the right end behavior. How many turning points do you see here? Two. One right here, one right here. Alright, any questions about that one? Alright, let's try another one together. Alright, next one. Kaya, what's the degree? 4. Okay, so is it even or odd? Alright, Antonio, does it have a positive or negative leading coefficient?
Odd.
Good. Positive 1 right here. So, Camden, what's going to be the end behavior? Up and good. Even has the same end behavior. It's positive, so both are going up. Alright, for my x-intercept, I set what to 0, Kayla? What do you set to 0 for your x-intercept? Okay. How do we factor this one? Anybody? How many terms are there? 3. Do they have anything in common? No. So what do you think? Bust them up. Good. Or A times C. That's what I call it. So A times C would be 1 times 1, right? Which is what? 1. Can you think of any factors of 1 that can add together to get negative 2? Negative 1 and 1. Good. Everybody see that? They multiply to get positive 1, add together to get negative 2. Everybody see that? Okay, so then how would I write them as 2 binomials? Instead of x in both of these, it'd be what? X squared. Because x squared times x squared gives us x to the 4th. Then both of these would just be what? Minus 1, minus 1. Alright, so when I set both of these equal to 0, let me show you what this would look like. I'd have to add 1, correct? So x squared equals 1. Then take the square root and I'd get what? Good. 1 or negative 1. Oops. And wouldn't it be the same over here? Very good. Any questions about that part? Alright, Solomon, to find my y-intercept, I set what to 0?
You said the 4. Wait, so on the y-intercept?
Mm-hmm. Do y'all know why we set x to 0 to find y-intercept?
Find a y.
Then let me show you. Catch mouse. Catch red. Alright. I'm going to draw a graph up here. And I want y'all to come draw me some y-intercepts. Just draw like 2 each.
Oh, these three.
Alright, come on. That was funny. This is y, this x. No, just points. Give me 2 y-intercepts. Yep. Wherever your heart desires. Good. Now you draw 2. I'll take that marker.
Wherever.
The y-intercepts. Yes. They have to do what? What are y-intercepts?
On the y-axis. Come
Good.
on, man. That's I should do that.
That's good. Thank you. Alright, now, Katie, tell me what this one would be, the coordinate point. You can guess. 0, 5. Kayla, give me this one.
0, 3.
Kaya, give me this one.
0, -3.
Sure. And Kate, give me this one.
0, -7.
Okay. What do all of these have in common?
They got 0 in front.
So what is 0?
0.
X. All the time. Every y-intercept, x always has to be 0. That's why we set x to 0 for y-intercepts. And that's why we set what to 0 for x-intercepts? Why? Because this is always going to be y is 0 for x-intercept. Does everybody see why now? Hopefully that'll help you remember. So for the y-intercept, you set x to 0. So Jalen, tell me what I get if I plug in zeros for x's right here.
Yeah.
Good. So my y-intercept is 0, 1. We won't worry about number 4, but number 5, how many turning points are there going to be, Colby? Colby?
3.
Yes, that's correct. Alright, let's graph our points. So we can graph 1 and negative 1 on the x-axis. And we can graph 0, 1 on our y-axis. And our end behavior, we can go ahead and draw that. That's going to be what on both sides? Up. Now, let's look back at our multiplicities. What would our multiplicity be for x equals 1? 2. Because there's how many 1s here? 2. It showed up twice, so the multiplicity is 2. What about for negative 1? 2. Same thing. So they both have even multiplicities, so that means they're both going to do what on the graph? Bounce off. So when it hits this x-intercept, it's going to bounce off, go through this point. When it hits this one, it's going to bounce off, which would make sense because it goes up on both sides. So that's a rough draft of how your graph should look. Alright, y'all feel comfortable doing these on your own? Too bad, you're going to try it. Do these two on your own, and then we'll go over them. You need to find each 4 things we did, same thing as on the last page. Label each 4 things, then go ahead and sketch it. As you get done, raise your hand with both of them. When you get done with both, raise your hand so I can come by and look and see what they look like. So is this one on the degree? In factor form? Let me just go over that together for it, okay? Are y'all confused on the degree part?
No.
Okay. Just the degree part is the biggest exponent, right? Well, all of these are being multiplied together. So it's all one big x term when we multiply them together. Let's look at these separately. The 3 doesn't have an x, correct? This one does. When we fold it out, this is going to become x what? Yes. This one's already what? And again, it's all being multiplied together. If we multiply these together, what would the exponent be? That's the degree. Okay? So you just add the exponents. And now for the leading coefficient, you look at each leading term, the numbers. And we really don't care about the numbers, just the what? The sign. This leading one is what? This one is positive, because it's positive 1 out front. This one is. So what would happen if I multiplied a negative times a positive times a positive? It'd still be negative. Very good. So this is negative and even. Start from there. Once you've drawn these, sketch these, and I've checked them and they're correct, you can pack it.
When you said before zero, would you like something individually or as a group?
No, individually. And you don't even have to set because you know that's negative 3 equals 0. It's not going to help you solve for anything. So this one would just be what? Yep, x equals 2. And you set this equal to 0.
Oh, okay. Which one are you on?
No, that's right. It'd be not just 2, but what?
Part of it again.
2. What's square root of 4? It can be 2 or what? Even, they have to go the same way. Right? So they're both going to be what?
Oh, so I got this.
Since it's already factored, we just set each one equal to 0 here. So this will be x equals. And this one, is not x x squared. So it'd be x squared equals 4, right? So x equals 4. That's it. You just found all your x's. 1, 2, and 2.
Even or odd doesn't have to be positive negative, right? Even or odd.
I'm trying to figure this out because
This one is both positive, because the square is really
what do you mean? Like, can you show me what you mean? Yeah, it's what it is. Negative 1. 0 minus 1 is negative 1 squared, which is 1 times negative 3. Okay. Negative 3, and then... Let's go. 0 minus 1 is negative 4. Are you sure? Why did you get for your y-intercept?
where here? You have a square here. And you add them. Whenever you have
Okay, so maybe that, like, we want to add
whenever it's standard.
standard.
No parentheses. So that's why we put it these are exactly here, 2, 3.